Hi, everybody. Happy Wednesday. Second to last day of e-learning for this week because you have today, Wednesday, tomorrow, Thursday, and then we teachers have a training on Fridays. So you do not have any content you need to work on. So yay for you. Today we're covering lesson 7-8, geometric sequences. This is the last lesson of chapter 7 in your algebra book. So this is the last thing that we're going to do for chapter 7. Next week, we are going to go back to chapter 5 and cover two concepts that, like I told you before, really hoping that we do that in person. However, here we are. We're going to make the best of it because it's very important. So by the end of today's lesson, you want to be able to write and use recursive and explicit rules or formulas to illustrate geometric sequences. That probably sounds like a whole nother language, but we're going to talk about what it means to have a recursive formula, what it means to have an explicit formula, what is a geometric sequence. We're going to talk about all of that today. You 100% need your math spiral or some type of piece of paper and pencil because you've never seen these formulas written out before, and you'll have to copy them down so you can use them as a format. So pause the video, grab your math spiral, grab a pencil and a calculator. You will 1000% need them for today. All right, here's your introduction problem. Imagine you're working at Mrs. LeMan's grocery store. Every day that an item doesn't sell, it's marked down 20%. If a jar of exotic peanut butter is marked at $80 on the first day, what will the sale price be after 5 days? So that's like, all right, day one, it's $80. One day goes by, it's marked down 20%. Another day goes by, it's marked down 20%. Maybe because a jar of peanut butter is $80, that's why no one's buying it. I mean, I would, but whatever. So on day 0, we know the price is $80. That's what it starts with. Now, if it's being marked down 20%, that's the same thing as paying 80% for it. So if I was using my calculator, and let's just say I'm using my phone, I would do $80 times 0.8 because we're paying for 80% of it, and my price would be $64. Then another day goes by and nobody buys it. So again, I'm going to multiply it by 0.8 because we're still paying for 80% of it. And now it's $51.20. As you can see going through here, the price goes down and down until we get to $26.21. This is a geometric sequence. It's geometric because we're multiplying every single number down here by a common ratio or a common value. In this case, we're multiplying it by 0.8. You can kind of make a connection between geometric sequences and exponential functions because for exponential functions, we would always be multiplying our y values by a number, and we're doing the same thing with geometric sequences. So that's your quick introduction for our lesson today. If you have your notebook, this is geometric sequences. This is lesson 7-8 in our algebra book. And let's go ahead and get started. Okay, and I believe that this is actually the first question on your assignment too. A geometric sequence is a sequence of numbers with a common ratio. Common ratio. When you hear that or when you see that, you need to think about like, ooh, I can connect that to exponential functions. We also connect that to the operation multiplication. So if you've got a geometric sequence, you need to be multiplying numbers, okay? So let's take a look here. Let's say that I'm giving you 3 different sequences and we're going to identify ones that are geometric and ones that are not. So if I was thinking to see like, all right, is this a geometric sequence? To get from 2 to 20, I multiply by 10, 20 to 200, multiply by 10, by 10, by 10, by 10. Because I'm multiplying every single value by 10, 10 is my common ratio, and that is a geometric sequence. If I'm looking down here at my next one, to get from 1 to 2, I say, all right, I know 1 times 2 is 2, but then is 2 times 2 6? No, it's not. So because there isn't a common ratio here, because it's 1 times 2 and then times 3 and then times 4, that doesn't work. This is not a geometric sequence. And for my last one, ask yourself, how do you get from 5 to -5? Well, I know that I multiply by -1. Then I multiply by -1 again, gives me positive. Multiply by -1, multiply by -1, multiply by -1. Even though it's just flip-flopping between 5 and -5, our common ratio is still -1, which makes it a geometric sequence, so that one works. Now, here is the very, very new part, it seems kind of abstract. When we talk about geometric sequences, there's two types of formulas that we can use to kind of demonstrate what the sequence is and kind of help illustrate it. There is a recursive formula and there's an explicit formula. So in your notebook, create a T-chart and have on the top of one recursive formula and on the top of the other explicit formula. Here is what your recursive formula looks like. This is a useful formula if you have to find the next term in a sequence. Don't worry about that so much because we're not going to work on that much from afar. So your recursive formula looks exactly like this. A1 equals A. And then AN equals AN minus 1 times R. That looks like the most abstract thing, but we're going to make it easier as we go on. The only thing that you have to fill in with numbers are the parts that are highlighted here. This A, that's going to be the first number in your sequence, and I'll move that for you in like 2 seconds. So that's going to be your first number in your sequence. And if I were you, I would annotate that in your notes as well. Okay, so if I was giving you a sequence and I asked you to write the recursive formula, you'd start with A1 equals, and then you'd plug in the first number of your sequence. This R here, that is your common ratio. So if you're multiplying by 2 as you go on, 2 would go in for R. If you're multiplying by 3.5, that's going to go in for R. So you only need to fill in these highlighted portions. Everything else stays. I kind of think about this as like, remember like set builder notation when you had to have like A equals bracket and then your variable and then your line. It's like you have that set framework for every single one and then you just fill in different components. Very similar here. All right, so that was your recursive. Here is your explicit. This is going to be useful for you when you're finding the nth term, and by nth term, it might be like, oh, go find the 10th term in the sequence, go find the 100th term. That's when you're going to use your explicit formula here. So it is AN equals A1 times R to the n minus 1 power. A1, okay, is again just going to be the first number in your sequence. So when you fill it in, you're going to take out A1 and you're going to plug in the first number of your sequence. R is again just going to be your common ratio. And it would be helpful if I could spell common right. So here's what you need to copy down. Make sure you have everything in blue, We're going to practice doing this together, and I would copy down these examples too so you have them, especially for your homework. Okay, so here we go. Here's the sequence that I see. First of all, ask yourself, what is the common ratio? What are we multiplying by? And hopefully you see, well, 7 to 21, we multiply by 3. And 21 times 3 gets us to 63. So I know that my common ratio is going to be 3. If I was writing out the recursive formula, here's the basic framework for it. And then here's what I would write out. I'd have A1 equals. Now instead of A, I'm actually going to plug in what is the first value in our sequence. And I see that it's 7. And then down here, I'm going to just fill in what R is. I know that R is 3 because that's my common ratio. So if I asked you to write the recursive rule for the sequence, you'd write out A1 equals 7, AN equals AN minus 1 times 3. And that's it. If I asked you to write out the explicit rule, you're going to take out A1 and you're going to plug in the first value of your sequence, which again is just 7. And then you are going to take out the R and plug in what your common ratio is, which is 3. So it's just 2 different ways to write a rule for the sequence that you can look at. Now let's do another one together. So again, here's your sequence. We want to write the recursive rule and we want to write the explicit rule to demonstrate that sequence. First of all, I know that I'm going to have to identify the first number in my sequence, which is going to be 2. And then I'm going to ask, all right, what is my common ratio? What am I multiplying by? And hopefully you can see, all right, 2, 4, 8, 16, 32. My ratio is going to be 2 because I'm multiplying by 2 as I go on. So looking at the recursive rule, if I asked you to write it out, you'd write out A1 equals, instead of A, I'm going to plug in 2 because that's my first value within the sequence. Down here, instead of R, I'm going to plug in 2 because I know that I'm multiplying by 2. And now when you come to do your explicit one, it's super easy because you're just doing the same thing. It's just in a different format. So instead of A1, again, I'm just going to plug in 2 because that's the first value in my sequence. And then instead of R, I'm going to plug in 2 again because that's my common ratio. So far you know that a geometric sequence is a sequence of numbers that are being multiplied by a common ratio, and you know how to write a recursive rule and an explicit rule. Okay, so let's keep it going. Now, here's where the rule comes into play. Here's the sequence that we just looked at on the previous slide. But as we go on in algebra, it's going to ask you to say, like, all right, go find the 10th term, go find the 100th term. Could you write out the whole sequence to get all the way up to 10? Yes, but is that the most time efficient? No, it's not. So if I gave you this sequence and I said, go find the 10th term, you want to use the explicit formula to do that. So look back here. Here's the explicit formula that we came up with. This is the easiest to use when you're going to find the 10th term or the 100th term. So step 1, write out your explicit formula. Step 2, instead of n, we're looking for the 10th term. So I'm going to plug in 10 for n here, which doesn't affect your answer at all. And I'm going to plug in 10 for n right here. If I asked you to find the 7th term, you'd plug in 7 right here. If I asked you to plug in 6, you'd plug in the 6th term right here. Then you just need to go through and simplify. So I've got 2 times 2 to the 10 minus 1 power. Hopefully we can see that 10 minus 1 is 9. So I've got 2 to the 2 to the 9th. Now simplify what is 2 to the 9th power. I've got 2 times 512. And then I'm left with 1024. So the 10th term in my sequence is 1024. Okay. Last thing before we are all done for the day. If I gave you a sequence that looked like this, notice that your numbers are getting smaller, but that doesn't mean that it's not a geometric sequence. To find out what that ratio is, because it's not so easy to tell just based on the numbers, here's what you can do. Okay, so I see I'm going from 60 to 51 to 43.35. Here's what you can do. Take your calculator and do 51 divided by 60. And I see that I have 0.85. Then to check it, all right, I'm going to do 43.35 divided by 51. I get 0.85 again. So that's an easy way to find your common ratio, and you know that it's correct because that ratio is less than 1, and notice that your numbers are getting smaller. To like triple check yourself, start with your first number. So I'm going to start with 60 and multiply it by 0.85, and notice that I get 51. And then I can do that again, and I got the same thing. So if I was filling in my formula here, and I'm just going to write right over the numbers here, I know that for my recursive, it's going to be A1 equals the first term in my sequence. So instead of A, I'm going to have 60. And then instead of R, I'm going to have 0.85. Yikes. For my explicit, instead of A1, I would take that out and I would plug in 60. And then instead of R here, I would plug in 0.85. And then if I asked you, go find the 75th term in the sequence, you could use your explicit formula over here, and then instead of n, plug in 75, and then simplify from there. Okay? So I think that that's everything for today. I know that was a lot of very new information. It might be helpful to go watch the video again, make sure you have everything written down. Your assignment for today is the geometric sequences Schoology check. Take it 2 times for your highest score. And please make sure that you are reading carefully. Okay. Also, don't forget that PS number 6 is due by 11:59 tomorrow night. That is the fast food portion graph where you're drawing 3 conclusions from it. Other than that, stay amazing. You guys are wonderful. See you later.